Right, so we're going to start off by looking at section 3.7, which is on solving systems of equations. But we're not going to do it algebraically, we're just going to do it graphically. All right? Okay, so just as a reminder what a system of equations is. Okay, it's when you're solving two or more equations for two or more variables. Okay, we're going to stick with two equations, two variables in this section. And this is pretty much the limit of what you can do graphing. Okay? When you have to graph two equations with two variables, it's two-dimensional. If you go to three equations with three variables, now it's three-dimensional. Three-dimensional graphing it's hard to do, obviously, by hand. And also the calculator we're using doesn't do it. Okay, so graphing is definitely limited, but works very well if you only have to do two dimensions. Okay, very, very, very quick. When you're solving a system that has two variables, we're basically going to look for where they cross. Right? So the solution is a coordinate. Okay, how many values are there in an ordered pair? Two. All right, so we're going to be looking for two answers here. There's going to be an answer for, generally, what are the two letters that we use with an ordered pair?
X and Y.
X and Y. Okay, so we're going to have an answer for X and an answer for Y. Okay, some people, they like to write their answer like X equals, Y equals. Okay, you can do it that way. Or you can just write it with parentheses and put a comma. Okay, I'm probably just going to write it as an ordered pair. Right, so to solve a system graphically, all we have to do is calculate the points of intersection for the graphs. Okay, if we're going to solve graphically, what's one thing you have to be very careful about when you're graphing in general? It'd be having to do with your window. Yep.
And make sure the size of the window is.
Okay, why would that be important? What could happen if the size of the window isn't correct, especially with this? Yep.
We could be missing like an intersector, like we wouldn't be seeing the full line thing.
Yeah, we could be missing an intersection point. Okay, we could have a point off the screen. So make sure you know what kind of graphs you're working with. For example, like parabolas, they have a U shape. So if you had a U shape and a line, you could think at most it's going to cross two times. Okay? Maybe it only crosses once. Maybe it doesn't cross at all. Right? But at most, it could only cross two times. All right? So if you had a window like this, you might be missing something. So always make sure you adjust your window. Okay. Any questions on that? All right. So our first one says to solve graphically. Okay, we have two variables. Okay, so it's going to be two-dimensional. And the x's and the y's don't have any exponents on them. Okay, so this is it's going to be a very simple graph. What kind of graphs are these both going to be when we draw them? Oopie?
Yeah, parabola, but
No, parabola would have to have squared in it to have a parabola. But even simpler than a parabola,
Just a line.
they're just going to be lines. Right? So lines can cross at one point. They could be parallel and never cross. Or they could be the same line. All right, so now let's just take each equation. And we've got to get it into a format, if we're going to graph it on the calculator, okay, where y is by itself. All right, so Pat, can you tell me my first step to get y by itself?
subtract 2x from the left
Okay, and
and add it to the right. Or subtract from the side too.
yep, make sure we do the same thing on both sides. And Derek, can you give me the right-hand side? Thinking of it in like mx plus b form.
Negative 2x plus 5.
Perfect. It's not wrong to write 5 minus 2x. It's just slope-intercept form. That's the order we generally do it in. Okay, and Tyler, my last step, I got to get rid of that 3. So what do I have to do to everything here?
Just divided by 3.
Just divide everything by 3. All right, so there's our first equation. Y equals negative 2/3 x plus 5. All right, next one. We've got negative 3x plus 5y equals 21. Pretty much the same steps. Okay, move the term with the x to the other side. That cancels. Okay, and Dalton, on the right-hand side, what will I have here?
3x plus 21.
Good. I like the order that he wrote it in. He said the x term first. It's exactly what we want. Okay, and last step, divide everything by 5. All right, so here's my slope, 3/5. Here's my y-intercept, 21/5. Okay, are these lines parallel? No. They have different slopes. Okay, so they're definitely going to cross that one point. So let's type it in. All right, so if you're going to, there's a couple ways you can type it in. I think the easiest way is just to type negative 2/3 in parentheses and then put an x. If you don't put parentheses, it might mess up. Okay, plus 5/3. And the next one is 3/5 x plus 21/5. Okay, I'll start with the standard window. If that doesn't work, we'll adjust it. Okay, so there's our first line. There's our second line. And where they cross, that's the solution. So second, calc, intersect. Pick a point on the first curve, second curve. Now, if there were multiple intersections, you got to put the guess closer to the one you want. In this case, there's only one. Okay, so we get a nice answer, negative 2, 3. That doesn't always happen. In fact, usually the answers are pretty messy decimals. But our first one comes out pretty nice. Yep.
Can you go back to the first screen of the calculator where you typed in?
Where I typed it in? Yep.
Yeah. I got parallel line.
Right, let me just take this so we have it. You can look at it. Right, now when you write your final answer, again, you can do it two different ways. Put x equals, put y equals. But don't forget to write both answers. Okay, however you want to do it. I just write it as a coordinate. That's x, that's y. Okay? Or write it just like that, either way. Okay. Any questions on that? Right, so we'll just try one or two more of those, and then that'll be it for this section. Okay, so that's all we're doing here. Yep.
Was it the 3/5 negative? Or
The 3/5? No, that one was positive.
Oh,
But the negative was on the 2/3.
yeah, it's vertical.
Yeah. All right, this one's a little bit more complicated because we've got these higher powers. We've got a parabola for the bottom one, and the top one is a cubic. Right, so we could have definitely more than one intersection point. Right, Cheryl, do I have to get y by itself in this one?
No,
No, how come?
because the y is already by itself.
Oh, it's already done. Right, so just type it in exactly the way you see it. All right, so we got negative x cubed plus 3x squared plus x minus 3. Okay, and the bottom one, negative 2x squared plus 5. All right, so I'll keep that over here in case people need to see it. Okay, we'll start with a standard window and then see what happens. Okay, how many intersection points does it look like I have? Yep.
3.
3? Why do you say 3? I only see 2.
Because one's probably off screen.
Yeah, it looks like this red and blue line is getting closer and closer. So Brendan, what would I have to adjust to see it? Would it be x min, x max, y min, or y max?
Y min.
Yep. y min. Let's try -40. That might make it hard to see the other two now, because they're going to be a lot smaller on the screen. Actually, we can still see them. You know what? I think I need to go a little lower. Let's try -55. All right, so now I can see 1, 2, and there's my third one. All right, so be careful you don't just write 2 right away and say, you know what, I don't see the third one. It's off the screen. All right, so second calc, intersect. Let's see. Okay, and for your guess, make sure you get it closer to the one you want. All right, so we get -1.22. Okay, if anybody has the other ones, that would help us out. If not, we'll just find them. 2.03. Okay, so that's 1. Did anybody have one of the other intersection points? Yeah. Which,
the longest one.
you got this one?
I have x equals 4.86
4.86.
and y equals -42.39.
Okay, thank you. And does anybody have that second one? Yeah.
X is 1.34 and Y is 1.35.
So if I ask you for all solutions to the problem, that's what I'm looking for. Okay, there might be times where I don't ask you for all solutions. I just say, graph the following and find a solution. Okay, if I just ask you for a single solution, you could give me any one of these 3. Okay? But if I ask for all of them, that's what I want. Okay, any questions on that one? Right, let's just do this one algebraically. Right, so we are focusing on graphing for most of it. And you could do the same thing. Type the top one in y1, the bottom one in y2, and then see where they cross. Okay. But to solve it algebraically, we have y. We know what y equals. It's 3x. Anybody tell me what I do with that 3x to solve this? Yep.
You put it in the equation. 3x equals x cubed minus x.
Yeah, we just fill it in. We just take 3x, fill it in for y in the top equation. And generally, when we solve an equation, we like to get what number by itself on one side?
Oh, y.
0. Yeah, it's like you're getting the y by itself. So we put 0 on one side. Okay, bring everything to the other side. Minus 3x, minus 3x. What's negative 1x? Take away 3x. Negative 4x. Okay, and what do both of those terms have in common? X. And if I factor that out, take an x out of x cubed, what am I left with?
X squared minus
Squared. And take an x out of negative 4x. There's my negative 4. And now, if we're going to multiply one thing times another thing and get 0, one of them or both have to be 0. So either the first factor is 0, or the second factor is 0. Okay, the first one, there's nothing to solve. You set x equal to 0, you're done. Okay. Paige, how about on this one? What are my 2 steps to solve it?
Add 4 to the other side.
So add 4 to both sides
Square root it.
and square root. And can you tell me what my answers would be when I take a square root?
2 plus or minus.
Good. All right, so now I know all the x values that are solutions. 0, negative 2, and 2. But I'm not done. I got to get the y values. I don't have coordinates. How am I going to do that?
Oh, that baby.
Yeah, plug it back in. I got a formula. This is probably the simplest one right there. To get y, triple x. So Amanda, what what would I get if I take 0 and triple it?
You get 0.
0. How about -2 tripled?
You get -4. Oh,
-6. And 2 tripled again is 6. So sometimes graphing would take even longer, all right? I don't know which, depends how many points you have to find. It depends how hard the algebra is. Okay. Any questions on that one? All right, and I think we'll skip doing it graphically. Okay. All right. So for the rest of the week, we're going to focus on Chapter 4. Okay, so between today and Thursday, we're only going to get through 3 sections in the chapter. Okay, we have 4 days. We'll do 3 sections. Okay, today we'll do a full section. Tomorrow we'll do half section. Wednesday we'll do half a section. And then Thursday we'll do a full section. So in this chapter, everything is about rational functions. Okay, remember, rational basically means it's a fraction. All right, so we're going to look at fractions. And they're going to look something like this. Basically, we're going to look at functions where we've got a polynomial on the top and a polynomial on the bottom. So here's an example of what one would look like. That's a rational function. X squared plus 1, that's a polynomial, divided by x minus 3. Okay, that's another polynomial. Okay, the only thing you're not allowed to have in the bottom is 0. Okay, the bottom polynomial can never equal 0, because if it did, we'd be dividing by 0. Okay, and as we work with rational functions, we'll do a lot of things algebraically. Factoring is going to come up a lot. Quadratic formula is going to come up. Synthetic division will come up. Okay, later on. This isn't all today, but throughout the chapter. And graphing. Okay, we'll do a ton of graphing with these, but we're going to use the calculator to help us out. And there's another example of a rational function. Polynomial on top, polynomial on the bottom. Okay, any questions what a rational function is? Just a fraction with a polynomial on the top and the bottom. All right, well, a lot of times when we study new functions, domain and range always pop up, and that's no different here. Okay. The domain for a rational function is it's pretty straightforward. It's any number you want, as long as when you plug it in, it doesn't make the denominator 0. Okay, so you can plug in any number that you want, as long as it doesn't make the denominator 0. So if I ask you about the domain of f of x, you don't even need to look at the top. The top doesn't matter. You can plug anything into the top. Take a number, square it, and add 1. But the bottom, there's a number you'd have to be careful with. 3. Okay, the domain of f of x here would be every number except 3. Okay, 3 would cause you to divide by 0. All right, so the example we just did, f of x, find the domain. It's all real numbers except 3. Right, so you can write it that way. All reals except 3. Or if they want it as an interval, you can pick any number from -infinity up to 3, or 3 to infinity. Okay, I put the parentheses on the 3 because we can't pick it. Okay, any question on either notation? If the book doesn't specify or the test doesn't how they want it, I'd accept either answer. If they ask you for interval notation, I want it the second way. Let's look at B. Right, so Matt, I want to find the domain. Should I be focusing on the numerator? Just the denominator. I want to make sure the denominator is not what?
0.
Right. Right. So what I'm going to do this time is set the denominator equal to 0. Okay. And what's one way to solve a quadratic equation? It's a pretty fast way as long as it works. Yeah, we'll try to factor it. So we could try x and x. What about my signs? Yep, plus minus. And two numbers that multiply to give me 2 and subtract to give me 1. 1 and 2. Right, and John, should I put 1 and 2 or 2 and 1?
1 and 2. I mean, other way around.
The other way around?
Yeah.
All right, let's try it. So we get x times negative 1 is negative x. 2 times x is 2x. Negative 1 plus 2, positive 1. Yep, we're good. All right, so now this one is going to have two values we can't use. Okay, what are the two values I can't use for x's here? Yep.
-2 and +1.
Yes. So all reals except -2 and +1. Okay, if you were going to write this as an interval, you'd need to write 3 intervals. Does anybody have a question on how you write this as an interval? If you're asked to do that on the test? Yep.
Where did you write that?
You'd write it from -∞ to -2. Or you can pick anything from -2 to 1. Or you can pick anything from 1 to infinity. Okay.
What form's that called?
This is interval notation, writing it as an interval. Okay, the top is just like a sentence. Right? Try to think of the -2 and 1 as spots on a number line. You can pick anything in here, you can pick anything in here, or you can pick anything in here. You just can't pick that and that. So you've got 3 sections to pick from. Right, and example C. Actually, this one's even easier than B because it's already factored for you. Okay, so what are the two values that I couldn't use here?
+2 and -4.
+2, -4. Okay. This one I'm just going to leave it in sentence form. All reals except +2 and -4. All right, so the simplest rational function, okay, the easiest one you can have is this one. Just take x and flip it, 1 over x. Okay, let's graph that on the calculator and then see what happens as x gets really big towards +infinity and as x heads towards -infinity. Turns out the same thing's going to happen. Y is going to approach the same value as x gets really, really big or really, really small, negative-wise. All right, so let's graph 1 over x. Okay, here's our graph. Okay, if you have an older calculator, what it's going to try to do, it's going to try to connect it and draw a line in right there. That's wrong. Okay, this is not a continuous graph. Okay, in other words, to draw it, you have to pick up your pencil. That's how it should look. Okay, but older calculators are going to try to connect it. And it doesn't stop right here. Okay, that part keeps going down. That part keeps going up. Right, so what value does it look like it's approaching? As x gets bigger and bigger and bigger, it's approaching what? 0. Yeah, as x gets bigger and bigger and bigger, y is approaching 0. And you can see that, just go to your table. Okay, if x is 1, we're at 1. If x is 0, we can't do because that's divided by 0. If x is 50, we're at 0.02. 500, 0.002. Is it ever going to reach 0? No, because if I take 1 and divide it even by 1,000,000,000, it's very small, but it's not 0. Okay? Very small, but not 0. Okay? And same thing on the negative side. Plug in negative 100, 1 divided by negative 100, negative 0.01. Again, very, very small, but it never reaches 0. Does anybody know what you call that? If you have a graph that's getting closer and closer to something, but it never actually touches it?
I think I might be right. Might be wrong.
Yeah.
Asymptote.
Yeah, it's called an asymptote. Okay, so for this graph, the line y equals 0, okay, y equals is horizontal. This is a line that this graph in blue gets closer and closer to, but it never actually touches. Okay, it never reaches it. And if you want to find a horizontal asymptote, all you have to do is let x get really, really big. Plug it in and see what happens. And when I say really, really big, you can plug in a really, really big positive or a really, really big negative. Right, so these are all examples of asymptotes. Okay, the dotted line is the asymptote. Okay, here we have on the left a curve that's coming up and getting close to it. Now on the right, we've got a curve that actually crosses the asymptote. That's okay. Okay, when we're looking at asymptotes, we're not looking at what's happening when x is small. We're looking at what happens when x is big, like when x is 1,000,000, okay, or 1,000,000,000. Very, very, very far away. Is it getting close to something? And this one is. Okay, page 217's got all kinds of sketches of different asymptotes if you want to see them, but here's a couple. Okay, and that's also a good way to sketch an asymptote. Okay, if you're going to graph something on paper, put a dotted line. Okay, that's how we do an asymptote. Okay, first thing you want to always make sure you do, if they're asking you for horizontal is y equals, and then a number. Y equals, and then a number. Because if you put x equals, we're talking something different. That's not horizontal, that's going to be a vertical. Okay? So y equals is horizontal. And if you get confused, use your calculator and just type in y equals and put a number. And see, is y equals horizontal or vertical? Oh, y equals is horizontal. Calculator can't do vertical. Okay, can't sketch a vertical line on this calculator. All right, so to find our horizontal asymptote, let x get really, really big and see what that approaches. All right, so let's say x was 1,000. Okay. 1 divided by 1,000 is a number very, very close to what? 0. And if you take a number extremely close to 0 and add 2, you get a number that's extremely close to what? 2. That's your horizontal asymptote. Okay. As x gets really, really big, this fraction basically disappears. Pretend it's 1,000,000. Take 1 divided by 1,000,000. It's like 0.00000001. If you take that and add 2, you can have 2.00000001. It's very, very close to 2. Any question on that? All right, let's try this one. Okay, so in your head, ask yourself what happens as x gets really, really big. Okay, think about what happens to this fraction. Okay. And then once you know what happens to this fraction, take the number you're thinking of in your head and subtract 3 from it. Okay, so what's going to be our horizontal asymptote? Yeah, y equals -3. Any question on that? Yep.
I've noticed that every single one of them is the number that comes after one number x. Is that going to be a pattern that shows up for all of them?
Yeah, if it's simple like this, it's just the number that comes at the end. Yeah. You know, even if I did something like this, well, whether you take 1 divide by 1,000,000 or take 3 and divide by 1,000,000, it's still extremely small. So as x gets really, really big here, if you get stuck, just try an example in your head. Take 3 divided by a huge number, and then add 2. It's getting very, very close to 2. Okay, so this one also has an asymptote of y equals 2. Okay, just another example I made up. All right, so let's sketch this one. Okay, what does this plus 2 do at the end? Okay, if you were going to compare this graph to that graph, what does the plus do? Does it shift it left? Does it stretch it? Move it up? Move it down?
Lift up.
Yep.
It raises up 2 units.
Yeah, it's just going to take your basic graph and whatever you have here, move everything up 2 units. All right, so if let's just make a sketch. All right, in fact, I'll do this as a transformation. Okay, here's the original. Okay, and the plus 2 on the end is just going to shift everything up 2 units. Okay, so that was approaching 0. Now it's going to approach 2, okay, just like that. And the whole thing would move at once. Mine just separated into 2 pieces. There's your new graph, shifted up 2. That's it.
So that would be your horizontal asymptote then?
Yeah, now if I wanted to draw my horizontal asymptote, it's right there. It's y equals 2. Yep. Everything gets shifted up 2. Okay, any questions on that? All right, now we're going to look at something a little different. Same graph. We're not going to focus on what happens as x gets really big. We're going to focus on what happens as it gets very, very, very close to 0. Okay, can I actually plug 0 in for x? No. If I try, okay, put in 1 over x, go to my table. If I plug in 0, I get an error. Okay, but I can plug in numbers very, very close. What's a number that's extremely close to 0? Even closer than 1. I want to get like real close. Yeah, we get 0.001. What happens if you take 1 and divide by an extremely small number? It gets really big. Okay, so on the positive side, we're going way up to 1,000. What's the number very, very close to 0 on the other side of 0? On the negative side? Yeah, negative 0.001. That's also a really big number, but now it's negative. All right, so as x approaches 0 from both the positive side and the negative side, y heads towards infinity and negative infinity. This little symbol right here means as x approaches 0 from the positive side. Positive means right side. Okay, if you think of a number line, you can approach 0 from 2 different directions. This is the positive side, approaching 0. That's approaching 0 from the negative side. And when this kind of thing happens, it tells us that something's going on here. Okay, this graph is, as we get close to a certain number, it's exploding towards infinity or negative infinity. Well, that's a different kind of asymptote. Okay, that's called a vertical asymptote. Right? So if there's a number you can plug in, or a number you get very close to, and this y value is getting really, really big, either towards infinity or negative infinity, you have a vertical asymptote. What's the first thing you notice that looks a little different about how I wrote it versus horizontal asymptotes?
You're writing x equals instead of y equals.
You're writing x equals. Yep. Very important. Okay, so for vertical asymptotes, you're writing x equals a number. Vertical is x equals. So in general, if you think h is a vertical asymptote, okay, what you do is you plug in a number on your calculator very, very close to h. All right, let's say you thought 2 was a vertical asymptote. What I would do on the calculator, plug in 1.99. See if it's going up really, really big. Plug in 2.0001. One side's going to go up very high, one side's going to go down very low. If that doesn't happen, then the number that you think is an asymptote isn't. Okay? And kind of the simple way to say that, something we've already done, as long as your numerator and denominator don't have any common factors, your vertical asymptotes are the zeros of the denominator. It's what would cause you to divide by 0. So if you can find the domain, those values that we say are not part of the domain, those are usually your vertical asymptotes. Okay? So you don't have to do anything new, as long as you can find the zeros of the denominator. Does anybody remember what would happen if we did have a common factor? For example, if I did x minus 2 times x minus 3 divided by x minus 3. I agree that 3 would make the denominator 0, but I wouldn't have a vertical asymptote there.
You draw and cancel out.
Right, because these would cancel out. Does anybody remember what that looks like?
X minus 2.
X minus 2, but what would happen at 3?
No, oh, it's got a
Something you can't see.
It might be a gap.
Oh, repeats twice.
It's not an asymptote, it's a break in it. But does anybody remember what we called it?
It's a hole.
It's a hole. All right, if you graph this, it's going to look just like the line y equals x minus 2, but there's going to be a very small hole at 3. Okay? Change this 3 to some other number, make it a 1. Now I got a vertical asymptote at 3. I don't have any common factors in the top and bottom anymore. Okay, so always make sure you check for common factors. Right, so let's find the vertical asymptotes of this. Okay, first thing, they're asking for vertical. Which letter should I put on the left, x or y? X. Okay, just type it in and use your calculator. Okay, it is important that we put that in parentheses if we're going to type it in. And I think a lot of you can figure this out without actually typing it in. Okay, but if I wanted to check it, what's a number that's extremely close to what we think the asymptote is? Yeah, we think the asymptote is 2. So what's something very close to that?
1.9.
Yeah, I'm going to go even closer. 1.99. I'm at negative 100. Okay. What's a number just a little bigger than 2? 2.001. We're at 1,000. Right? So because that's happening, that shows we do have an asymptote at 2. Okay, the next one I don't think we need to graph. Let's just figure out what the asymptote would be. Okay, anyone think they can tell me without graphing what the vertical asymptote is here?
Negative 3.
And how would we write it?
X equals negative
good, x equals. If this was a multiple choice question on a test, I would probably list y equals -3 as a choice. Okay, but that wouldn't be vertical. What would be my horizontal? Sorry. What would be my horizontal asymptote here?
Positive 1. Y equals positive 1.
Yes.
X equals 1.
Well, if it was x equals 1, we'd have to have that plus 1 there.
So X equals negative.
Yeah, x equals -1. Remember, that -1 just shifts it down 1. Okay, I know it's kind of confusing because you see the
So do we just flip the denominator of the positive 3?
yeah, because if you were going to solve this, if you were trying to get that equal to 0, you do the opposite.
So just flip.
Yep.
Okay.
Yep. So think of the denominator. You're solving it, and to do that, you do the opposite. Yep. Yep.
So the -1 doesn't have anything to do with the vertical aspect?
Nothing. Nope. I could put -14 here. The answer to this problem is still the same.
What is that, -1?
Oh, it's going to shift up and down.
Yep, that's just going to shift. It's going to move the graph up and down. Okay. The only thing that affects vertical asymptotes is if you push them left and right. If you take a line that goes up and down forever and move it up and down, it's still in the same spot. Yeah.
So then would -1 be the horizontal asymptote?
Yep. -1 is the horizontal asymptote. Yep. All right. All right. So if we're going to sketch this one, okay, what is the -2 going to do to it? It's going to move it 2 units, but be careful about which way.
Right.
Yeah, it's going to move it 2 units to the right. Okay, so the way you figure that out, look at what comes after the minus sign. Okay, all the horizontal stuff is always backwards. Okay, it's always confusing. All right, but you look at what comes after the minus sign, and it would move it 2 units to the right. Think of where your vertical asymptote would be. If it helps, start with that. Okay, take your grid. Draw in your vertical asymptote. X equals 2. Okay, and as long as you know the that basic curve that it's going to do, okay, it always has that basic shape, okay, unless we flip it or do something else to it. All right, so this part curve down like that. This part curve like that. Okay, any questions on that? All right. So one more graph, and then we'll finish up with our last type of problem. All right, so this one they want us to find the horizontal and vertical asymptotes, and then describe the transformations. Did we shift it? What did we do? All right, did anybody see what's a little different about this function than when we graphed this one? We graphed this one, all of those. Okay, this one, look at that numerator. It was always 1. Well, this one's not. Right? So what we have to do here, before we can actually look at it, we got to make this equal to 1. Okay? And the way we do it, I'm going to use synthetic division. Okay? Just divide the bottom into the top and see what you get. And then we're going to have a problem that looks exactly like the ones we've had all along. All right, so with synthetic division, what number do we put on the outside?
I mean, for X amounts, like, would be 5.
Yep. Just the number that's after the minus sign. Okay. If you want to do long division because you like that better, you could, but I think this is a little faster. And what are my coefficients?
2 minus 13.
And minus 13.
Negative 13.
Yep. I'm going to bring down my 2. Okay, 5 times 2 gives me 10. and -3 is my remainder. All right, so here my quotient is, okay, we got 2. Minus, okay, that's my 3. My remainder over my denominator. That's how you write your answer. Your quotient, and then your remainder over your denominator. All right. Now, we normally don't write it in that order. If you want to rewrite it, you could do something like this.
Is that the vertical or the horizontal? Or is that both?
Well, we can see both in here now. Okay, this +2 at the end has something to do with it, and this -5 has something else. But now it's just written more like we like it. Okay, we've got a number on top, we've got the variable in the bottom, and then we have plus or minus a number at the end. Okay. Number on top, variable in the bottom, plus or minus a number at the end. Okay, what's my horizontal asymptote here? Yep, y equals 2. Okay, now maybe some of you could have seen that without synthetic division, but it definitely makes it a lot easier. And my vertical asymptote?
X equals 5.
Good, x equals 5. Okay, that one I think you could have gotten without doing synthetic division. You could see that one right away. Right, and the last step, describe the transformations. Okay, first thing, the -5. Okay. What does the -5 do? Yep,
Shift it left, back.
it's going to shift it
Oh, right.
right 5 units. All right. Next thing we focus on is the 3. Okay, think of the 3 as doing something like this. Okay. It's basically like sticking a number in front. Okay. What happens when you stick a number in front?
Oh,
That's what happens there?
going to expand or shrink.
Yeah, that's a vertical stretch. Anytime you stick a number in front or put a number in the numerator, same thing, that's a vertical stretch. Just say by a factor of 3. And now the negative also causes something else to happen. Okay, what does that negative do?
Flips it.
Flips it over which axis?
Okay.
Yeah, it's going to flip it vertically. So if you had something like this, now it's shaped like that. It's flipping it over the x. It's the same thing all these numbers have always done for every function we've talked about. And now the last thing is the +2. That's going to shift it up 2. Right. So those are the 4 things to describe how to get that graph from the original.
How would you have seen that the horizontal is 2 from not doing this?
Yeah, it's hard to do without doing the synthetic division. But I'll give you a nice shortcut, a little trick tomorrow that helps on some problems. For now, I'm not going to give you any complex problems to divide. They'll be pretty straightforward.
And when you do the synthetic division, you're dividing the 5 on the bottom.
Yep. Yep, 5 and then the 2 and the -13.
For the first step, why do we shift right 5 instead of left? Because it's a -5.
Yeah, think about if you were going to set it equal to 0 and solve it.
Oh, so we change it so.
Remember, you'd have to add the 5. The vertical asymptote is at 5. Yeah, anything with horizontal, it always does the opposite of what you think. Yep. All right, and last thing we'll look at for today. Okay, we've looked at mixture problems before. I think mixing two things together to make a third thing. This type of mixture problem is a little easier than what we've done before. Okay, it's a lot easier. Okay, let's say, and this will be our first problem we do, we'll use this example. I had 50 ounces of liquid, but only 35% of it was actually acid. How would I find out how many ounces of acid I have? Okay, I've got a 50-ounce jar of liquid, but I'm telling you only 35% of what I have is acid. The rest of it's water. Yep, so it's like you do it as a percent. Just take the part that you think is acid, 0.35, multiply by how much you have. You're basically finding 35% of 50, which in this case is 17.5. Right, so that's all you need to know to do our last example. All right, so what I'm going to do is I'm going to take 50 ounces of liquid. Okay, I have this, it's already mixed, it's on the table. And I'm going to pour 100% pure acid into this stuff that's already been mixed. Okay, so by pouring pure acid into this 50-ounce solution, what am I doing to the concentration?
They're making the acid concentration.
I'm making it higher. Okay, I'm making it stronger. Putting pure acid into what I already have. Okay, first thing I want to do is find a graph of the concentration. Right, and to do that, okay, your concentration, okay, as Jamie just said, okay, you think of it as like it's like a part out of the whole. Okay, you take the amount of acid you have divided by total amount of liquid.
So do you have 135% acid in there? Or?
Well, let's start with how much acid we have. Okay. How much acid is in the solution before we do anything to it?
17.5.
Right. We have a total of 50 ounces, but only 35% of it is actually acid. So we have 17.5 ounces of acid. And how many ounces are we going to add to it? X. We're going to add X ounces of pure acid to what we have. Okay? So that's how much acid we have. Okay? Now I just need to find out how much total liquid I have. Okay? How much liquid do I have before I add anything to it? 50 ounces. And how much liquid am I adding? X. There's my concentration as a function of X. Okay, now just think logically. If I keep pouring pure acid into this, what can the concentration approach? It'll approach 100. Could it ever reach it? No. I'm starting off with something that's already diluted. No matter how much stuff you keep pouring in that's pure acid, you always had a little bit that was diluted. Okay? You can't get it to 100%. All right, so let's graph that. Keep that horizontal asymptote in mind. 17.5 plus X. Okay, divided by 50 plus X. Okay, this is a graph of the concentration. Now, what's the lowest the concentration could go if I don't do anything to it?
35%.
Yeah, it's already at 35%. It can't go any lower than that. Can't take the acid back out. And what would 35% be as a decimal? 0.35. Okay, the concentration can't get any higher than 100%. And what would that be as a decimal? 1. Okay, X is the amount of acid. Does it make sense to add negative 10 ounces of acid? No. Okay, we can't add negative. How much could we add? As much as we want. So let's just say we add up to 400 ounces of acid. Right, so you can see what happens to your concentration. At first, when you start adding it, the concentration goes way up. But then as you keep adding more and more and more, does it have a big effect on the concentration? No. Maybe the first 100 ounces or so brings it up a lot. But after that, it doesn't go up as much. Okay, and the last thing they want to know, and we're going to use our graph and what we just learned in the last section, is how much acid should I add to make it exactly 75% strength? Okay, how would I figure that out? I want to use my graph to figure out how much acid I would have to add to make it exactly 75% strength. Yeah?
175 in the
Well, if we plug 75 in for x, remember x is the acid we're adding. So that would tell us if we add 75 ounces, what the concentration would be. But you're on the right idea. You're on the right track.
Put a line in at 75 and then find the intersect.
All right, and so what should I type into y2? 0.75, yeah. All right, just make sure you change that percent to a decimal. That's exactly what you want to do. That red line marks where the concentration hits 0.75. Find our intersect. So if we add 80 ounces, it'll get us to exactly 0.75. Okay. Any question on that? So 80 ounces. Yeah.
Can you scroll up a little bit?
Okay. The only scenarios here that would be impossible is if they said how much acid would you have to add to get like a 30% solution. You can't do that because you're already at 35. And you can't get to 110%. Okay, you can only have 100%. That's as pure as you can get. Okay. Any questions on that? All right. So does everybody have this? Good? Yep.
I typed it on my calculator. For some reason, 0.75, it turns out to be 2.23.
Okay, I'm guessing something's not right with the, just make sure the equations are right. Okay, parentheses and everything. So 17.5 plus x in parentheses, divide by 50 plus x in parentheses. Okay. If you're not getting it, let me know and I'll come help you in a second. All right, so the homework for the graphing ones, just try 8, 9, and 10. Okay, on page 207. And then for the stuff on asymptotes and horizontal vertical asymptotes, that's page 222. Okay, 3 to 7, 11 to 21. Okay, just the odds. 23, 31, 37, 38, and 48, just parts A and B. I think this is a mixture problem. There's a part C, but I don't want you to do it. Okay, so 48, just A and B. All right, so we'll take a look at that tomorrow. And then tomorrow and Wednesday, we're just going to stick to doing half a section. Okay, so we'll slow down a little bit next 2 days.